Hello everybody and welcome back to another Calculus 2 video. This time we will talk about partial derivatives. Partial derivatives are used to take the derivative of a function with several variables. So in particular we will be discussing a function of two variables. But everything we do for a function of two variables can be done for a function of three variables, four variables, and so forth. Okay, so let's say you have a function of two variables. It could be something like x squared plus y cubed plus x times y to the power 5. If I want to take the derivative of this function, I can either take the derivative with respect to x or with respect to y. When I take the derivative with respect to x, then I treat the y variable as a constant. Y is constant. So here's what I mean by that. Let's say we want to take the derivative with respect to x of something as simple as this. Okay, so the derivative of x squared with respect to x is just 2x. Now, we said y is a constant, and if y is a constant, then y cubed is also a constant, so the derivative with respect to x would be 0. Let's say, what else do we have here? Let's take the derivative of x squared y plus 3y plus y over x. Okay, so again, remember, if you take the derivative with respect to x, y is a constant. Okay, so let's look at the first term. You have x squared times y. Y is a constant and it's multiplied, so nothing happens to this y, right? Because it's multiplied as a constant. All we do is take the derivative of x squared, so you get 2x y. This would be just like if you had a situation, let's say you had x squared times 3, right? Think about how you would take the derivative. Since 3 is a constant and it's multiplied, you don't do anything to it, right? It stays the same way, so you only take the derivative of x squared. And that's exactly what we did here. Next, y is a constant, therefore 3y is also a constant. The derivative becomes 0. Next, this term you can think of as y times x to the power negative 1. In this case, y is multiplied, so it stays. And we only take the derivative of x to the power minus 1. So the minus 1 comes down. And then you subtract 1 from the top. And in the end, we can write our final answer this way. Let's try maybe one more example. What would be the derivative of sine of xy? All right. Here we will use chain rule. So remember the chain rule. First, you take the derivative of the outside function. And then you have to multiply by the derivative of the inside function. When I take the derivative of x times y, I have to keep in mind that y is a constant. So only take the derivative with respect to x, which becomes 1. So you get 1y. So in the end, you can write your answer this way. Okay? So I hope that this makes sense. Just like with the derivative with respect to x, the derivative with respect to y works the same way. So if you kind of busy here. Take the derivative with respect to y of a function. Yes, some dude is trying to ask a question. So if I take the derivative with respect to y, then x is now a constant. So let me show a couple examples. Let's say we want to take the derivative okay? I recommend for you to pause the video and see if you can do this question yourselves first. Okay? Let's do it together now. So when you take the derivative with respect to y, x is constant, remember. Now what happens? For x, it's a constant, so we get a 0. X squared, again, is a constant, so this also becomes 0. And then y squared with respect to y, this gives us 2y. And over here, x is a constant, but it's multiplied, so we have to keep it. And when you take the derivative of y cubed, it gives you 3y squared. Okay? So you can see this is exactly the same as what we've done before, but we're switching the roles of x and y in this case. Okay, now let me discuss a little bit about the notation. So if I take the derivative with respect to x of a function, we sometimes use notation f subscript x. Okay, so when you see f subscript x, that means we're taking the derivative with respect to x. And similarly, the derivative with respect to y, sometimes we denote with f subscript y. Okay. Now, next, let's discuss second derivatives. Just like with the first derivative, the second derivative can be taken either with respect to x or with respect to y. And using this notation, we have the following. So, okay, let's say you take the derivative of f with respect to x. So that's your first derivative. Okay? Then you can take this first derivative and take its derivative with respect to x again. So we call this the second derivative with respect to x. And we denote it also with f double x in the subscript. So this means the second derivative with respect to x. You take the derivative with respect to x twice. What else can you do? So you can also, let's say you take the derivative with respect to x first, and then this expression, you take derivative with respect to y. So again, we did differentiation twice. This is represented with fx y. Okay, so this notation means essentially that we are taking the derivative with respect to x first, and then with respect to y second. So you get the idea. We have f double x, we have fxy. Similarly, we have fyx and f double y. Okay? Let me just quickly show you an example of using the new notation and calculate the second derivative. Okay, let's say we have a function x cubed plus y squared x to the fourth y to the 5. Okay, so we have this function, and let's calculate first fx. Okay, so what does that mean? It means that we have to calculate the derivative with respect to x, and y will be constant. So what do we get? 3x squared. This is a constant, so you get 0. And okay, here y to the 5 is a constant, but it's multiplied, so we will have to keep it. We only take the derivative of x to the 4, which becomes 4x cubed. And then the 2 is 0. Next, let's take the derivative of x twice. Right? So what this means is that we have to take our first derivative and take the derivative with respect to x of this guy. Well, we already found the first derivative, fx. It's right here. So if I take the derivative again, I'll get 6x, and here we get 12x squared y power 5. Right? Great. Let's say we want to know f subscript y. This means take the derivative with respect to y. Well, let's look what happens. This becomes 0 with respect to y. Okay, so I'll write 0. This becomes 2y. Over here, x to the 4 is a constant and it's multiplied, so we keep it. Taking the derivative here, this gives us 5y to the power 4. And 2 becomes 0. Okay? And then what can I do? I can, let's say you want to calculate fyx. Okay, so what this means is that you want to take the derivative of f with respect to y first, and then take the derivative with respect to x. So basically, we want to take the derivative with respect to x of fy, which is 2y plus, and this guy is 5x to the 4, y to the 4. Okay? So we take the derivative with respect to y first, that gives us this expression, and then we take the derivative with respect to x, which will give us what? This becomes 0 with respect to x, and this becomes what? This becomes 20x cubed y power 4. Okay, so I hope that makes sense. We will use the second derivative later on to find the maximum and the minimum values of a function.